So here we're going to look at prime factor trees, and just to remind ourselves, short list of primes up here, not all of them obviously, but a few. These again, all numbers divisible by themselves in 1 only. And if we take a minute to remember also what factors are, these are things that you can times together to get a number. So for instance, 10 has factors of 2 times 5, we'll get it, and 1 times 10, we'll also get 10. So 10 has 1, 2, 3, 4 factors. So a prime number factor tree is when we take a number, any old number, for instance 28, and we think about trying to break it down so that we can get just keep breaking it down into factors that are smaller and smaller until we get only primes that are left. So for me, if I'm trying to think of factors, remember 1 is not a prime, so the next number I might try to divide 28 by would be 2. So let's try 28 divided by 2. So 28 divided by 2 is going to give me 14, because 2 times 14 will get me 28. And 2 is already a prime, I can't go any further, but let's look at 14. 14 I can also divide by 2, and I get 2 and 7. 2, 2, and 7, all of those are prime numbers, so this is a complete prime factor tree. What that means is I can say that 28 is equal to 2 times 7, timesing up the ends of every single branch in the tree. If we look at another example, like the number 120, same idea, we look for things that can be divided. We look for primes that we can divide into this. So first one that's usually pretty easy for an even number like this would be 2. So 120 divided by 2 gets me 60. 2 is a prime, so we'll look at 60. 60 can also be divided by 2, and we get 30. 30 can also be divided by 2, and we get 15. And 15 cannot be divided by 2, but it can be divided by 5 and 3. And now we've got 2, 2, 2, 5, and 3. Those are all individual prime numbers, so that's a complete prime factor tree. So we could say that 220 is equal to 2 times 2 times 2 times 5 times 3. And one thing that you can do with these prime factor trees, once you've got them written out, you can kind of group things together to look for other factors. So for instance, I could take those two and times them together and do 4 times 7 to get me 28, and that's factors of 28. Or I could look at the other pair and do 2 times 14, and that would also get me 28. So you can group these into different clumps to try to get things that times together. For instance, 2 times 2 is 4, times 2 is 8. 8 and 15. So 8 times 3 times 5 is 15. That will get me 120. I could do a different grouping. What if I just did those two? 2 times 2 is 4, and then times up the rest. 2 times 5 is 10, times 3 is 30, so 4 times 30 will get me 120. So if you get a prime factor tree finished, you can go through and make some interesting, if you have to look for a lot of primes, or if you have to look for a lot of factors of a number, that can help you sort out what all the options are. Let's look at one more example of a prime factor tree. And let's take a look at maybe a number like 78, something that's not an even number. So again, for prime factor trees, you're looking for small primes that you can divide this number by. And I guess 78 is divisible by 2, but let's challenge ourselves. Let's not do this divided by 2 in the first place. Let's think of another divisor. Just to go through that trick, I might notice that 7 plus 8 is equal to 15, and I know that 15 is divisible by 3, so I know that 78 will be divisible by 3. So let's try that one first. If I divide 78 by 3, I'm going to get 26. And 26, maybe now I'll divide by 2, 2, and 13. So in this case, I've got a prime factor tree. 78 is equal to 3 times 2 times 13. Those three are primes numbers, and that's as far as I can go. So the factors of 78, if I wanted to list factors after getting that, would be 1 and 78, and then look at different combinations here. I could do 3 and 26 from that group. 3 and 26. And we can see that as 3 and 26. Or you could do something like 6 and 13, looking at combining those two and the 13, or looking at it like this, circling up those two numbers, timesing them, and having the 13. And those are all the ways we can combine the end numbers on those branches, 3, 2, and 13, to get our factors, and then remembering that you always have 1 and the number itself as a factor as well. So give a go, try to find yourself some prime factor trees of some numbers, and see how it works out.